Okay, this tutorial is about histograms. Now, I know you've already gone through the PowerPoint slides that I put on Blackboard that give you a basic idea of the sequence of clicks required within Excel to create a histogram. But beyond that, I wanted to give you an example, maybe a more real-world example, still a simplified case, but how a business context might be helped if you know how to use histograms to summarize data. So let's look at this file, Machines, from Blackboard. If you look at this file, there's quite a bit of data here. It's organized into 3 columns, Machine A, Machine B, Machine C. So this is just data that was created, fictional data as an example. Under each machine, let's say, for example, these are the diameters of products that are coming off of that machine. Say they're ball bearings. And ideally, we'd like the diameters to be 100. Right? So machine A, if you scroll down, you'll see we have, I believe, 100 observations for each machine. So machine A, the first ball bearing it produced had a diameter of 96. The second one had a diameter of 100. Perfect. The next one, 83. So clearly there's some variability. These machines aren't perfectly creating these ball bearings with a diameter of 100 every time. You can see machine B, it made one that was 98, 94, 103. Machine 3, the same thing. So let's say you're given this report and you're asked to comment on the performance of the machines. Which machines are doing the best? Which machine has potential problems, etc. Well, if we just know how to do simple descriptive statistics, we can put some formulas here in the sheet. That might be a good starting point. So we can just find the average diameter for each machine. That makes sense. Let's scroll down to the bottom of the data set, equals average, and grab all the data. So I highlight the bottom data point, hold down Shift, and I just hit page up until I get to the top. Come down 1 to make sure I don't get the label. So now I have equals average of A2 to A101. That looks right, so I hit Enter, Control C, and I copy that over. So now I have the average performance of these machines in terms of the diameters that are coming off of them. So machine A, slightly high on average, but pretty close. Machine B, more than 1 full unit below the target average of 100. And then machine C looks perfect with an average of 100. Right? But this isn't the whole story, as you know. So in a lot of business contexts, certainly in this one, the average isn't really what we care about. It's the variability that we're interested in. So on average, it could be having a diameter of 100, but that's certainly not the whole story. We can look, for example, at min and max. So again, and we could do all this through the descriptive statistics functionality of Excel, but we can also do it directly with formulas. What about the minimum of machine A? What's the smallest diameter that's coming off of that? Equals min. I just grab all the machine A data. So actually, some coming off of machine A have a diameter of 63. What about the max? Equals max, all the machine A's, or 133. So there's quite a bit of variability. Although machine A is very close on average to that 100 target, there's a lot of variability. I can copy these over as well. So now we see a little bit more of the picture. It's still not the best thing to base a business decision on. We know the mean, but we know a little bit more about the dispersion around that mean, which is really critical. Right? So with these ball bearings, if the mean happens to be about 100, that's not what we're worried about. Think about it in terms of, so if I have one hand in the freezer and one hand in the oven, my average hand temperature might be perfect, but the average hand temperature is irrelevant, right? What matters is the variability. My hand temperatures go from very cold to very hot. Same thing with this. What matters is how much variability is there in the ball bearings coming off of these machines. So instead of trying to do these with individual Excel formulas, let's try some histograms. So let's delete all of these pieces of data I put at the bottom of the sheet. Now I'm back to just the 100 observations for each. If you notice with those pieces of data, across all of the machines, the ball bearing diameters varied from about 60 to almost 140. So if we do histograms, remember, in the base Excel functionality, now it gets easier with other programs, but in base Excel, I need to define the bins for my histogram. So I'm going to put bins over here, and I'm going to start them at 60 and go all the way to 140. Right, so I have a bin at 60, 65, and now one trick with Excel is it's pretty good at guessing what you're trying to do if you copy. So if I select that 60, 65, go to the bottom right corner here until my cursor becomes a plus, and start dragging down, Excel will guess. Did you mean to be going in increments of 5, 70, 75? And I did. So I'll just drag down, and Excel guessed correctly that what I wanted was a series of numbers by 5s starting at 60 all the way to 140. I'm going to use these as my bins as I create histograms. Okay? So let's go to the Data Analysis tab and select histogram. We're going to do them individually for each machine at a time. let's do machine A. The input range, I'm not going to grab the labels. I'll just grab the numbers. I click the top number. I hold down shift and start using the arrow keys. A quick way for me to get to the bottom of this range is to hit the end button and then the down arrow key. It will immediately get me to the bottom of the range. So that looks right. Input range A2 to A101. Bin range. Now I need to tell it where my bins are for this histogram. And that starts, I need to move this aside. My bin range starts in F2 and goes all the way down to F18. Right? Those are the bins I want to use to create this histogram. I don't have labels, so I won't check that. And I do want to chart output. So when I click OK, it creates a new sheet and gives me a quick histogram of machine A. And I can expand this a little bit, make it a little easier to see. If I don't like certain components, it's very easy to alter. If I don't like this word frequency, that doesn't add a lot of value to my histogram, I can just select it, hit the delete key. If I want a little more meaningful name than histogram, I can call it machine A. This is the performance of machine A. So now I start getting an idea of, although the machine A average was almost exactly 100, I have a tremendous amount of variability here. In terms of variability, machine A does not seem to be doing very well. Let's do the same thing for the other two machines. Data analysis histogram. Now my input range, I want to get the machine B data. So it's B2, hold down shift, start using those arrow keys. If I want to quick skip to the bottom, I hit the end button down. That's really handy if you have, say, 10 or 20,000 rows of data instead of 100. Everything else looks okay, same bin range. I click OK. Now here's the histogram for machine B. It looks a little tighter in terms of the dispersion. Again, if I just look at the average, I don't see anything about this. But now if I look at this complete distribution of diameters, I see machine B is a little tighter. So let me rename this machine B. Now I'll do it one more time for machine C. Data analysis histogram. Again, all I need to change is the input range. I'm still using the same bins. End down to get to the bottom of the range. Chart output. And here's machine C. You can see very small amounts in some of these, but very tight. All right, so now I have a little more data on each of these three machines. So now if I'm going to report back on the performance of these machines, I have at least in just a few minutes of kind of a picture of how each machine is doing. And I can even put them on the same page. So I want to emphasize that this is a little bit cumbersome in base Excel. There are other tools, and we'll talk about several other tools in this course that are much quicker and easier to do these types of comparisons. But if all you have is the base free version of Excel, no add-ins, you can still do a lot in terms of these comparisons. Let's put them all on the same sheet. There's the machine A histogram. Here's machine B. So I can just select it, Control C to copy it, and put it right here underneath machine A. I'll have to make these a little smaller because I want all three to fit together on the same sheet. Get that closer. So again, this takes a little time, and the other tools I'll show you are much easier, but it still isn't too much trouble to get a quick visual comparison. Machine C, I just hit Control C, copied it here. Let me make it a little smaller. And now I have all three of these for easy comparison among the three. Right? They're not perfect. I could line them up a little bit better, but you get the idea. So now here's a quick, easy way to report on these machine performances. Right? Instead of just reporting the means, which doesn't tell me anything, I say, here's the distribution of diameters coming off of machine A. You can see there's a lot of variability. Here's machine B, here's machine C. So a couple things we can say right away. Machine A does not look good. Right? On almost any measure, machine A is performing very poorly. Right? Quite a few ball bearings coming out with diameters well below the 100 target, many well above. In fact, I'll delete machine A just to get it out of the comparison so we can make these other two a little larger. Then I would probably report on the machine B versus machine C comparison. And this is a little more interesting because it really depends on what you're looking for. So you can think about these two. Which would you prefer, machine B or machine C? Well, machine C has a lot of ball bearings right around our target of 100 or a little more, but it does have some big outliers. Machine B has a little more dispersion, but it doesn't have any significant outliers. So this is basically where you would start your discussion, your managerial discussion about which machine is doing better. You could talk, for example, about tolerances. It depends on how tight a tolerance we need. So let me just put some lines in here Oh, sorry. Let me just put a simple line in here. Actually, I'll just cut, yeah, here it is. Sorry, simple line. What if my tolerances are any ball bearing between this diameter and this diameter is perfect, well within spec. Our customer will be extremely happy. Well, if that's my tolerance, I might like machine C. So machine B, all of these are missing that spec. There's quite a few out there, whereas machine C, almost every single item is within that spec. I still would need to think about these outliers. So if an extreme outlier, like 125 diameter, breaks the next machine in the process, then machine C is a no-go. But if I'm just looking at the percentage that are within spec, machine C looks good. And on the other hand, if my tolerances look like this, in other words, any ball bearing between these two lines is perfectly acceptable to the customer. Now machine B starts looking better because every single ball bearing that I took off machine B is within those tolerances, whereas machine C has a few that were out. All right, so that's a quick and easy way to take a bunch of data, put it into some easy pictures that really help you have the managerial discussions. There are other tools, as I mentioned, to do this, other ways to generate these histograms. And in fact, another tool called box plots that really makes comparison of multiple populations like we just did very easy. We'll be talking about box plots later in the course when we get into the more advanced Excel functions. But that's an overview of how you can use histograms to quickly and easily summarize some empirical data.